Hi there, I hope you're having a great day. Today in this video we're going to be taking the turret enemy from my previous videos and getting it to look at and fire at the player whenever the player is in range. We'll also be triggering our animations in code and creating a particle effect to also trigger to be treated as the turret's projectiles for the player to dodge. If you would like to see more game dev content, then please subscribe to the channel, and onwards with the video. Here we are in Unity with our turret model from the previous video. What I want to happen is when the player is in range, I want the turret to aim at them, trigger the animation, and then fire a particle effect that the player will have to dodge. So the first thing we're going to handle is the aiming. We're going to create a new empty object, and I'm going to name this ground turret. I'm going to put the turret enemy mesh inside of ground turret and rename turret enemy to just be mesh. I'm also then going to make sure that my position is on 0, 0 for both the ground mesh and the mesh itself. And then we can reposition the ground turret object. We're going to go over to add component and we're going to look for a sphere collider. I already have it here. We're not going to worry about changing the radius here because we're going to do it all in code. We do need to set it so it is a trigger and make sure that the center is on 0, 0, 0. Alright, we're going to program in some aiming. So we're going to right click in the assets file, go create and C# script. We're going to call this enemy aiming. Going to open that bad boy up. Magic up some code. Okay, we have many a variable here. We start off with our private variables. We have a transform target, which is how we're going to store what we want to look at. Sphere collider, which is the sphere collider we put on our object a minute ago. And a ball for is the target in range. Set to false by default. We then have a serialized field for the transform of our turret pivot. This is just so we can drag our turret pivot point into this so we can easily control it. Then we have two serialized fields here, one for targeting range and one for turning speed. Sphere collider equals get component sphere collider is where we are setting the sphere collider variable to equal this sphere collider here on our turret. Sphere collider.radius equals targeting range. This is where we are setting the size of our sphere. And like I was saying earlier, we don't need to mess around with it here. We'll look at the update method and aim in a second. Down here we have mono behavior methods on trigger enter and on trigger exit. Remember we set our collider to be a trigger. So when something enters the trigger that has a collider, the on trigger enter code will run. In this code, we check what the tag of the colliding collider was. In this case, if it was the player, then we set target in range to be true and set the target to be the player's transform. With the tags, you have to make sure that in Unity, your player has their tag up in the top right here set to player, otherwise this won't work. On trigger exit is a method that activates whenever a collider leaves the trigger zone, or the collider, and in this one we are just checking if it was the player that left, and if the player did leave then we set the target in range to false. Down the bottom here we have an on draw gizmo which will just draw a wire sphere over the object's position at the size of targeting range in the color of red. Alright, back up in update, we are running the aim method. So what is aim doing? If target in range has evaluated to true, get the direction we need to face. To do this, we take the target's position and we minus our position and we normalize that. We then go over to Quintonians and no, I still don't understand them. And we create a look rotation Quintonian and then we use the method look rotation using direction as our variable inside of that. We then set the turret pivot.rotation to equal Quintonian.slurp, which is a method that allows you to smoothly move between 2 points in a rotation. Inputting our turret pivot.rotation, our look rotation, and then our turning speed times time.delta time to make it frame independent. Quintonians are mainly to do with rotation. They are a lot of maths. I don't 100% understand them. I will have the Unity docs down below if you want to read about them. Okay, back in Unity and we drag our enemy aiming script onto our turret, not onto our mesh, onto our ground turret. And then we want to go into our mesh and find our pivot and drag that into the turret pivot slot. The red circle is there, it's just really tiny, so let's make it nice and big. There we go. Let's also move these enemy spawners. So now when I hit play, the turret should snap straight to the player and be looking at them, and if I fly out the circle to the left, it should stop aiming at me. Cool, it is aiming at me. Alright, we fly out the left. It's not aiming at me out here. Go back in. Yep, it is aiming at me. Beautiful, we love to see that. One thing of note that you may have to fix is if your pivot, if your Z-axis line, the blue one here, doesn't line up with your turret's barrel, then that's going to cause this to aim in different directions and not aim correctly. If that is the case, you may have to do some adjusting in Unity to make sure that the blue arrow or the Z-axis arrow is going down the same way as the end of your turret. Now we're going to get the animation to play at the correct time. We're going to want to add an animator component to our ground turret. And we're going to create a new C# script. I'm going to have the animation handled within the firing script. So we're going to call this enemy firing. Right, now I'm going to make some code. I'm going to yoink some of the code out of the temp turret animation trigger that I made in my last video and magic that up now. Okay, we have these three variables at the top here, which are private. We have is firing, which is instantiated to false. This will be changed to true whenever we are firing. We're then going to have a float called time holder, which is going to hold our time to shoot variable so we can keep resetting back to it. We then also have our animator. We then have two serialized fields, fire delay, which I'm going to use to help sync up the firing to the animation, and a time to shoot, which is going to control how long it takes for the cannon to start firing. Down in our start method, we set the time holder to equal time to shoot so that we can keep resetting back to it, and we cache our cannon animator using get component in children animator, because we're going to be putting the animator onto the mesh. Update, we are ticking down time to shoot using minus equals time.delta time, and then we start an if statement. If time to shoot is less than or equal to 0 and the is firing variable is false, that's what adding this exclamation mark here means. It's basically the same thing as saying it equals false. Then we're going to start a coroutine, fire cannon. When that's finished, we'll be doing time to shoot equals time holder, resetting the time to shoot back to whatever it was originally. What a coroutine does is it allows you to give up control midway through the method, wait for a certain amount of time or a variable to finish, and then come back to it. In order to use a coroutine, we have to declare the method to be an I enumerator. Down here, the yield return new wait for seconds fire delay is our condition to wait for. In this case, it's going to wait 1.5 seconds before then continuing on with this code. Is firing will now equal true, because the cannon has started the firing process. We set the trigger in our cannon animator, cannon firing. This needs to match up with your trigger, which we will check momentarily. Here will be where we fire the particle effect. We'll be coding that in a little bit. After all that is done, we set is firing back to false. Now if we jump back over to Unity, we want our mesh to have a animation controller. So I'm going to drag the previous animation controller I had onto it. Create an animation controller, just right click in your assets window, create, and then there's animator controller. Inside the animator controller, I've set up a trigger. This name has to match perfectly with the caps and all with the set trigger you've put here. What this animator is doing, we enter into an idle state, which is the cannon just sitting still. Once the cannon firing has been triggered, then we'll start playing the cannon firing animation. Back to idle until the trigger is triggered again, and then we'll go back to cannon firing and back and forth, back and forth. So we want to put the animator onto our mesh, and in our ground turret, we want to drag on enemy firing. If we hit play just to check if that works, 5 seconds, the animation should play. Yep, there we go, nice. Now I don't think there's any checks to stop the animation from playing after the player has left the bubble. There's not, but we can handle that. We'll just create a quick check to see if the player's inside, and then reference that check on our firing. We'll just jump into the enemy aiming script. We're going to create a public ball and call it is target in range. And all we're going to do with that is just return target in range. If it comes back true, we know target's in range. Comes back false, we know it's not. We go over to enemy firing and we're going to quickly add another private reference. We want to reference enemy aiming script. So we're going to call that enemy aiming, enemy aiming. We can use the get component method to grab that. We want to use the get component method and not the get component in children, because this component is on the same object rather than being in one of the children. And now I'm just going to wrap this update method in an if statement. The update method has been wrapped up to now check if we are actually aiming at an enemy or not. To do that, first we check that enemy aiming is not null. Aiming.isTarget in range, which runs this method here and returns true or false based on whether the isTarget in range variable is true or false. So if we hit play, the time to shoot should be ticking down when we're inside the circle, inside the sphere. The animation should play. Nice. And then we leave the sphere, timer stops ticking down, back in the sphere, carries on ticking down. Nice. Okay, cool. Sorted that little thing out. Now we're going to create a particle effect, which is going to serve as our cannon's projectiles. Before we work on the particle system, we're going to grab our ground turret and drag it down to our assets window to prefab it, and then we're going to double click it to enter into the prefab. Inside the prefab, we are going to set the transform to be 0, 0. We're going to right click in our hierarchy and create a new empty object. And we're going to call this particle spawn. And then I'm going to position that at the front of the turret where we'd want the particles to spawn. I need this green rotation axis to match up with the turret, and then I'm just going to child that to our pivot so it moves with the cannon body. We're then going to right click on the particle spawn and go to Effects, Particle System. I'm going to name this object enemy projectile FX. And then you'll notice that you have all of these settings over here to play with. I'm in the way again. We have all of these settings on the right here to play with. The only ones that we're going to mess with are the main settings, the shape, the emission, the size over lifetime, collisions, and the renderer. I'm not going to go over all of the settings, just the ones that I'm messing with. For the duration, how long this lasts for, we're going to set that to 1 second. And I'm also going to turn off looping. You might want to turn on looping just so you can see what is going on here. But with looping off, you'll have to press play every time you want to see the animation. So for now, I'm going to turn looping on just so I can see what I'm changing and what I'm doing here. I'm going to set the start lifetime to 0.7. This is how long our particles will live for. So as you can see, that has now shortened down their lifespan quite a bit. I'm going to set the speed, which is how fast our particles are traveling, to 500. And as you can see now, they're all flying out like crazy. Set the start size, which is how big the particles are, to 5. I want them to be purple, so I'm going to set the start color to be a nice purple. We want to set the simulated space to world. This will affect how the particles react inside the game world. If we're on local, we want this set to world, otherwise it doesn't work properly and the particles just end up flying in weird directions. Play on awake, we want that turned off because otherwise it's going to fire the particle system as soon as this thing spawns. That's all we need to do in the main settings. In the emission settings, we're going to set the rate over time to be 0. This is how many spawn over time. And then we're going to go to bursts and we're going to add a burst and make quite a nice like cannon shot, but we want to change this to be a count of 1, so it just shoots out one singular particle, and we can just leave it at that. In our shape module, we're going to be changing the angle to be 1, so it only shoots up in a straight line. We're also going to set the radius to be 0.0001, and then we can leave the rest of the shape settings alone. So with these two set super low, it's just going to spawn out in a straight line and shoot straight up as it's doing here. We go down to size over lifetime and check that on. We're going to click on the size graph to open up this graph down here, this curve graph. And I want them to start off super big, so we go start big and then end small. With an extra dot around here, so it stays big for longer and then gets small towards the end. Can't really see it now because of how tiny it is, but we'll fix that in a moment. We want to turn collisions on. We want to set the lifetime loss to be 1, so when it hits something, it will just kill the particle immediately. That way we don't have to worry about destroying the particle when it hits something, we just have to worry about the player taking damage. And now down in the renderer, we're going to change the render mode to be stretched billboard, change the length scale to be 10, which will then make it nice and long. And we are going to give this a material. We need to right click on our assets window, create material. And we're going to name this enemy particle material, or enemy particle matte. Also make that a purple. Go back to our projectile and drag that into the material slot here. And here we have a nice little beam that comes out. If you mess with the settings, you can get different effects, different beams coming out. If you gave the material a texture, then you'd have a nice texture on the particle as well. But this will do for now. We want to go back to emission. Nope, we want to go back to the main settings and turn off looping. And then I'm going to duplicate the particle spawn and drag it over to the other turret's cannon. Now we just need to trigger this in code. We go back to our enemy firing script, and I'll add some quick code to this to show you how to fire them. Okay, in our is firing script, I've added this private particle systems array called bullet particles. The two brackets here make it an array. Down in start, we're getting our reference to that by using get components with an S in children. This will go through all of our children and grab every particle system that is inside one. And then down in fire cannon, we have a for each loop, for each particle system's PS in bullet particles, so every single particle system that's inside the bullet particles array. We check that it's not null and then we play it. And this should work if you have 5 particle systems, 10, 50, 100 different cannons. They should all fire at the same time. I'm going to jump back into our prefab because I forgot to do something on the material. We're going to change the shader of the material to be a particle standard unlit. And we're going to turn on emissions and make that a deeper purple. So we hit play and we should see some nice purple particles coming towards us. And if they hit us, they should disappear. Oh, there was the particles. Can they hit us? Oh, they did disappear. That's good. That's what we want. I think I need to change this so that the cannon fires a little bit ahead of the player, because otherwise it's going to be a bit too easy to dodge. And I also need to make it so that the player loses health when these contacts happen, or they get destroyed if they get hit too many times. I also need to add a sound effect to it, but all of that can come later because this video is already getting pretty long. We now have a turret that can take aim at the player and shoot at them, shooting out little particle effects. I also recommend that you go into your prefab, you find your particle systems and you prefab them as well. Just so then you can make changes to them, or you can then put these particle effects onto other enemies that are also shooting. And make sure you tidy up your assets folder, mine is starting to be a bit unruly. But for now, that's it for this video. I'm going to make one more enemy type before I start refining and making these enemies a bit better. My next set of videos will be on a helicopter enemy that I'm going to have hovering at the top of the screen that can spawn either facing the player or facing side on from the player, either shooting them or firing rockets at them. And then once that enemy is finished, it will be time to start refining these and working on the health bar and the shaders and whatever else. So if you'd like to keep up with the progress of this game and maybe learn something about how to make your own game, then please subscribe and please leave a like on this video. Thank you very much for watching. I hope you have a great day.